Hello guys, today we are going to learn how to design a parabolic grassland waterway without any duration steps. So we are given that the discharge flowing in that grassland is 3.6 meter cube per second and the longitudinal slope is 3.5% or which is equal to 0.035, and we have also given the permissible velocity as 1.8 meter per second. By saying permissible velocity, I mean to say that this is the limiting value of velocity. If we exceed the velocity than 1.8 meter per second, then the chances that soil erosion will occur increases, or there is a higher susceptibility of erosion. Another thing we have given is the Manning's coefficient n, which is equal to 0.045. Now we need to assign the value for the top width of the parabolic grassland, that is t, and the depth as d. So let's proceed. So we have collected our given data here and we need to design a parabolic grassland waterway like this. The first step is we assume the discharge a little bit higher than the given. So we assume a little higher, that is 3.8 meter cube per second, which is a bit higher than 3.6 meter cube per second. But the thing is, why we keep the discharge more than the given discharge? It is similar to the factor of safety taken in various engineering purposes. For safe limit, we increase the value of discharge here. Another thing is we also assume the velocity. Since the permissible maximum velocity is 1.8 meter per second, so we assume that the velocity we take is slightly lower than this value. So we take velocity as 1.6 meter per second, or you can assume 1.5 or 1.7 meter per second, whichever you like. Then from discharge and velocity we can calculate area A, that is given as discharge divided by velocity. So we divide 3.8 divided by 1.6 equals 2.375 meter square. Another step, we find the R, means the hydraulic radius. To find hydraulic radius, we have got the Manning's equation, that is velocity equals to 1 over n times hydraulic radius to the power 2 over 3 into square root of slope. So in this formula we substitute the values as the velocity is 1.6, the Manning's coefficient n is 0.045 from here, and the value of slope is 0.035, and the only unknown variable is r, or the hydraulic radius. So we can easily find the value for r to be 0.239. In next step, we know that the hydraulic radius equals to the weighted area over the weighted perimeter. So simplifying, we can get the weighted perimeter equals to weighted area divided by hydraulic radius. So we do 2.375, that is the area, divided by the hydraulic radius, that is 0.239, to get 9.94 meter. I need to say that the parabolic grassland waterway is not in the shape given here. The depth should be smaller than the top width. I have only shown these to describe or to illustrate you that it is parabolic in shape, but in actual the shape is like this. The depth is quite smaller than the top width. So let's continue. We have already found the area to be 2.375 meter square and perimeter as 9.94 meter. Now we need to remember one formula, that is for parabola the area is given by 2/3 of top width times the depth. So substituting the values, we get 2.375 equals 2/3 of top width times the depth. We can find the equation as d equals 3.562 divided by t, which we call as equation number 1. Similarly, for perimeter there is a formula. So we apply this equation, and what we do is we substitute the value of d from equation 1 in here. So d is replaced by 3.562 divided by t, and simplifying this equation we can get this equation, which is in fact the fourth degree equation in t. So we get 4 results for it. So solving this equation, we get the value for t as 9.9 meter or 1.59 meter. Yes, it is the fourth degree equation, so we must get 4 solutions for it. The other solutions of t are not the real numbers, I mean to say they are complex number, so we don't need them. So we got the 2 values for t, and from equation number 1, d equals 3.562 divided by t. So whenever t equals 9.9 meter, the depth will be 0.36 meter. When we substitute 9.9 over here, we can get this result as 0.36 meter. And whenever we put t equals 1.59 in this equation, the depth equals 2.24 meter. But looking at the practical figure, the depth of the parabolic grassland is always smaller than the top width. But from the second solution, we see that the top width is smaller than the depth, that is 1.59 is smaller than 2.24 meter. So we neglect this solution and take our solution as 9.9 meter as the top width and 0.36 meter as the depth. And you can assume the freeboard yourself.